Welcome back. Today we are going to continue with the 2016 free response questions. We're going to start with number 4 here. And let me see here, go to view, full screen. Here we are. And this question on the 2016 is pretty easy. You all should do pretty good on this one. First question, part A, says, consider the following differential equation. And we want to be able to find the second derivative in terms of x and y. So this, of course, this is going to be implicit because this is our implicit because we have both x and y in terms in the function. So they already given us the first derivative. So to take the second derivative, dy2 dx2, very simple. It's just going to be take the derivative. Now we're taking the derivative, of course, with respect to x. So we're going to get 2x minus 1/2, and then we're going to take the derivative of y with respect to x. Well, we already have that. That is this dy dx. So that is just going to be this x squared minus 1/2 y. And there is our second derivative with respect to x. And on the AP that year, that was worth a whopping 2 points. Now, the question people always ask is, well, what if instead of doing 1/2 y, instead of 1/2 of the derivative, what if we left it at dy dx? Well, the AP won't accept that. We can't do that because it does say in terms of x and y. So you will have to replace that. All right. For part B, now they're saying let y be a function of x. And this is a particular solution to the differential equation whose graph passed through the point. So we've given this point right here. So we know that the value, so we know that f of -2 is 8. That's what they're telling us. They want to know if the graph has a relative maximum, minimum, or neither at the point. And typically we would use the first derivative test. However, in this case, the first derivative test will fail because we really don't know anything about the function itself. So we're actually going to use the second derivative test. And if you need to look that up, I have a video on that earlier on this year. Please go check that out. That's a great video. But basically what the second derivative test says is if the first derivative is 0, if dy dx is 0, and if the second derivative is greater than 0, we know that the function is concave up, and therefore we have a minimum. If the second derivative is less than 0, we know the function is concave down, we have a maximum. So that is our rule. So the first thing we're going to have to do is, of course, check to see if the first derivative equals 0. So to do that, we know that dy dx at the point -2/8 equals, and I'm plugging it in to my derivative, which is from part 1. So we're going to plug that in. It says -2 squared, -2 squared minus 1/2, 1/2 y, which is 8. And that is indeed 0. So this is a critical number. And in the second part, take a look now at the second derivative at the point -2/8. And now we're going to plug it into our second derivative, which is what we got for part A. So we're going to have 2 minus 1/2. Now there are 2 ways we can do this. I could just plug it in, which is obviously going to be easy. We have x squared, so that's going to be 4 minus 1/2 y, which is 8. And if we simplify that, we do get 2, which is greater than 0. Well, that is telling us that the function is concave up. And because the function is concave up, this is a relative minimum. So we can say that f of 2, or -2, sorry, is a relative minimum because the second derivative, in trouble, because the second derivative is greater than 0. And that's your answer. So let's point this out. All this is just worth 2 points. Pretty easy. So that should be an easy 4 points for us right there. So, but you do want to make sure that you can do these problems right here. So that's quite parts A and B. Now, part C, here's an old friend of ours. It says, let y equal the function g of x be a particular solution to a differential equation. And they're saying g of -1 is 2. What they're really saying also is that the y value at -1 is also 2. We want to find this limit. And this is just a limit problem. Now, I will tell you this. This question caused a lot of anger amongst teachers because nobody was expecting how much work they expected everybody to show on this one. So let's plug everything in. If we plug in, we're told g of -1, this right here, g of -1 is 2. So we know this is going to become 2 minus 2 on top over plugging in here. Plugging in -1 here, we can get 3 times 0. So notice we get 0 over 0. Now notice we do not write 0 over 0. That's a no-no. AP will give you no credit for that. But writing it this way, 0 over 0, 0 over 0 is perfectly okay. So obviously this is L'Hopital's, and we would say this is indeterminate. Therefore, by L'Hopital's rule, we now take the derivatives. The limit as x approaches -1, take the derivative at the top, we get g prime of x. On the bottom, we're going to get 6 times x plus 1. And if we do this real quickly, we're going to get g prime of -1 over, and of course the bottom here is 0. We just got to find out what g prime of -1 is. To do that, let's go back. G prime of -1, well, I know that g prime is equal to f prime, or dy dx. And from part A, we know dy dx is x squared minus 1/2 2x, sorry, x squared minus 1/2 y. And so if we plug that in, oops, sorry, I got my pen stuck here. If we plug that in, g prime of 1, this top here becomes 0 again, and the bottom is still 0. So this is, again, indeterminate. Therefore, by L'Hopital's rule, we take the derivative one more time. G double prime of x over, this just becomes 6. And if we plug in g double prime of 1, well, g double prime of 1, of -1, sorry, is -2. So what we get is -2 over 6, or -1/3. And there's our limit. This was tough. Using the L'Hopital's was worth 2 points, and that's the entire process. So if you don't show the 0 over 0 like this, equals 0 over equals 0, and you don't show the indeterminate by, therefore by L'Hopital's, you don't get those 2 points, and your answer was worth 1 point. That's a lot of points for a L'Hopital's question, but it's a really, 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 really good one to have there. So do that one again. Try that one. That's a really good question right there to know how to do. All right, the last one, part D, says let y equal h of x be a particular solution for the differential equation h of 0 equals 2. And they're saying use Euler's method starting at 0, with 2 equal steps. Remember, Euler's is just tangent line twice. That's all they really want us to do here. Tangent line twice. So I'm going from 0 to 1. So if I'm starting at 0, I'm going to 1. What number is in between? 0.5. And that's what I'm going to use here. So my first step, my point is 0, 2, they tell me. My slope, again, that comes from dy dx. Sorry, I dropped my pen. So the slope, dy dx, is given by the equation x squared minus 1/2 y. So that's my slope formula right here. That's from part A. So my slope, my point here is 0, 2. If I plug it in, we're going to get 0 minus 1/2 times 2, or negative 1. So we get y minus 2 equals negative 1, x minus 0. So there's my first tangent line. Now, we don't typically box in, so I should actually erase that. Don't box in your answer on the AP. I need to erase that. Hold on here. There it is. So don't box in on the AP. So let that be a lesson to you. All right, so what do we do next? Well, we plug in our first point. Well, we went to 0.5, so we let x equal 1/2. So we get y minus 2 equals negative 1 times basically 1/2. So what is y going to equal? Let's see. What does y equal here? We get 3/2. Okay, there's our y value. And now we go to step 2. Well, my new point, my x value we know is 1/2. My y value is 3/2. My slope, I plug it into our equation up here. Man, that becomes 1/4 minus 1/2 times 3/2. And if we simplify that, what do we get here? Let's see. That becomes 1 minus 3. So we get negative 1/2 right there for our new slope. So my tangent line, y minus 3 over 2 equals negative 1/2, x minus 1/2. And now we're going to let x equal finally 1. So we get y minus 3 over 2 equals negative 1/2, 1 minus 1/2. And when all said and done, you're going to get y equals 5/4 for your answer. You do not have to simplify. Heck, you could leave it like this on the AP, and they'll be okay with that too. But again, now I boxed it in. Do not box your answer in. Okay? Don't box it in. All right, so that is question number 4 right there. So if you continue on, we will move on to question number 5 in the next video. Please definitely go ahead and take a look at that, okay? All right, see you then.